Hi everyone, welcome to my channel. If you are new, please hit the subscribe button to watch more educational videos as this one. Today I am going to discuss about solar or DC street lighting. As you may all know that LED lighting is taking over traditional lighting technologies like incandescent, CFL and other technologies. And in case of solar street lighting and also other forms of lighting, this is not that different. Street lighting can be categorized into two parts. One that uses conventional AC electricity grid, or also known as AC street lights, and second, the one we will discuss today about is the solar street lights. Solar street lights are powered using solar energy and batteries and are therefore called also as DC street light. So at the heart of every solar street light you have something called a controller. This is the controller. This controller has two functions. First, it helps in charging a battery like this one. This is a 10 ampere or 12.6 volts 3 cell lithium iron phosphate battery, or simply lithium battery. So the first thing it does is charge these batteries using solar energy, that is through a solar panel, and then at night this charge controller behaves like a LED driver there. So this is not just an ordinary charge controller, this is a charge controller and an LED driver. As you can see, there are three pairs of wires. The first, positive and negative, goes to solar panels, the second goes to batteries, and the third goes to load. And in our solar street light case, this load is LEDs in MCPCBs. Now this whole setup is a complete mess. I'm sorry about that, but why I made this mess, I have to make it clear before I proceed. As I said, that this solar charge controller uses solar energy. So this power supply, it's a DC to DC converter, it is behaving like a solar panel. Or in other words, I would say it is simulating that it is a solar panel. Then I have this shunt. This shunt is responsible for measuring the battery ampere hour. This it's not just a shunt, it also has a voltmeter through these resistors. So it's also measuring the voltage and the current that is going through in and out of the battery. So this display is showing us the current battery voltage, the battery charging current, the wattage, the ampere hour, the watt hour, and the time that has passed. And finally, this is the load. Well, I did not use a LED load because I want to show you how this works. This meter is the display for this DC to DC power supply. One more thing I would like to say, that this type of charge controller or simply controller has an infrared remote like this one. Now this remote is used to set up its parameters and also read what the charge controller has to provide. Like, let's say if this battery is charging or discharging, if there is any sort of fault or error. This charge controller can also be used to signal the load to temporarily turn on and off as a test measure. Finally, how this charge controller works, let's discuss about this. Well, this type of charge controller, as you know, has 5 or maybe 7 stages. Typically I have seen charge controllers with 5 stages. Now what does these stages mean? No, this is not charging a stage. This stage basically dictates what will be the amount of light for a certain period of time. Usually at night this charge controller turns into an LED driver. So what it does, for let's say 6 p.m. to 8 p.m. it will light up the LEDs to 100% brightness. So 2 hours for 100% brightness. The next 4 hours it will, let's say, light up at 75% brightness, and the remaining in that proportion. And at the first light of morning, before the first light of morning actually, it will be lighting up the LEDs at 80%, but throughout the night the brightness will get dimmer and dimmer over time. Only at the morning the lights will again light up to at least 70 to 80% brightness. All this intelligence is provided through this remote, provided through user settings. There are several types of charge controller like this one. The one I have here is just a simple, I would say, on-off charge controller, or just simply a switching charge controller. What it does, whenever there is solar energy, it will directly connect to the battery, and when there is no solar energy, it will disconnect. And then we have PWM charge controllers, MPPT charge controllers. Those are much more efficient than this one. So if it was an MPPT charge controller, then we would have gotten more output. But now, as you can see, the input and the output are almost same. Almost same. There is no difference at all. Let me just power off the supply for some time, and you will see that the input is around 32 volts and it is set to 22 volt output and 2.4 amperes. So now, as we have turned off this charge controller, not the charge controller, I mean the solar power. So now this charge controller is no longer acting as a solar charger. It is discharging the battery through this load, and as you can see, it is already, the ampere is negative. The total load is around 6.6 amperes. So it is behaving as if it's night right now. So now if I turn back the solar energy, the LED output goes to 0. It's 0.07 volts at 0.03 amperes. It's almost 0. That means it's almost open. The light is no longer there, and almost after 5 hours it will be fully charged, because this battery is around 10 ampere hours. It's almost 9.85 amperes so far, and the time is around 4 hours, the charging time. I think that will be all. If you have liked this video, please share and don't forget to subscribe. Thank you.